Okay, so to examine question A, what type of interference will you get along these three paths? If I look at path A, all right, I find that the path difference here from 1 and from 2 is each 2 wavelengths. So the path difference, D1 minus D2, for every single point along here is going to be 0 wavelengths. You're still going to get constructive interference. However, the constructive interference is the waves from S1 and S2 travel both the same distance and constructively interfere at the point right along the middle of the two sources. Path B, um, as we were discussing earlier, if I look at path B here, one wavelength, two wavelengths for a point of constructive interference on here, and then if I look at the same for S2, I get one wavelength, two wavelengths, three wavelengths. So the difference between all those points of constructive interference, you will have a one wavelength difference. S2 has to travel a little extra distance, and that extra distance it has to travel is equal specifically to one wavelength more than path 1. Path C, okay, if we take any point here along path C, we're going to find that we have constructive interference. And when we look specifically at how much longer, path C, I'm just going to erase some of this first before I redraw. Path C, you're going to have the distance the wave has to travel for S2 is going to be, in this case, 4 wavelengths here, and for S1 would be 2 wavelengths. So the distance for the wave from S2 is always going to have to be 2 wavelengths more to reach the same spot to have constructive interference where those crests and crests line up and where the troughs and troughs line up. So highlighted here along path A, you're going to have constructive interference, and the path difference for the wave from S1 and S2 there is equal to 0. Along B, the path difference from S1 to S2, S2 is going to have to travel a distance of 1 wavelength longer to catch up and be in phase. In other words, catch up and have the crest and crest meet, or the trough and trough meet to have interference. And path C, S2 is going to have to travel 2 wavelengths more to catch up to meet a crest of S1. So along those paths, you're going to have constructive interference, and every time you go further and further away from path A, you have to add on 1 wavelength extra that one of the sources has to travel to catch up, to be in phase, to constructively interfere.